So very warm welcome to all the participants in this live interaction session, the second live or third in fact, second technical and the first one was more administrative. So the third live interaction session in this course. Now one of the things that we have emphasized in this IIT Bombay X is that we must have people come forward in terms of live interaction, in terms of discussion, in terms of posing questions, and more importantly trying to answer them on the forum. So, we are looking forward to participation from you in this live interaction session in larger numbers in future. I can see there are a few centers which have come, and I am also hoping that when we go to some of these centers, I will see some of the students also present, because in addition to the faculty, we would like the students also to interact. That is the advantage of being in IIT Bombay X and having this chance for live interaction. So with that little introduction, I would also like to introduce two of my coordinating teaching associates here. And I have on this side Abhinav Anand, and I am going to ask Abhinav to introduce himself to the whole audience. Abhinav Anand is doing his PhD with my supervision in educational technology, and he is going to work closely with all of you to carry out certain pedagogical studies which will help us enhance our offering of signals and systems. So let me now ask Abhinav to introduce himself and say a little word, say a few words.
Hello all the participating institutions and the participating faculties. I am Abhinav Anand and I am currently working under Professor Gadre in Educational Technology Department, and I have been currently like supervising all the pedagogical activities or the activities which you see on Moodle. So all those activities are being designed by a team which take care of all those pedagogical activities which you see. So I like to talk about a few things which I have came across while supervising all these pedagogical activities on Moodle. So I have seen a very little or very few participation in terms of doing all those activities on Moodle. So you can see, if you have went through all those activities, you would have seen in the Moodle timeline that there are 2-3 activities. The first activity is to complete a survey, which is an entry survey type of there is a multiple choice questionnaire which is there, and that questionnaire has been designed to get a feedback from the faculty participants so that we can improve the teaching learning in signals and systems. So please go through that survey and complete that survey, because it is a very important feedback for us, so as to in future we'll be rightly putting up the course and rightly carrying out all the pedagogical activities in signals and systems. The second activity which you will be seeing is activities on active learning strategies in signals and systems, like peer instruction and flipped classroom and blended learning. So the whole of the concept of this blended MOOC is basically based on this flipped classroom mode and which is an active learning strategy, the peer instruction which is also an active learning strategy, and also the blended learning part of it, where you have this online videos available to you, and then you see it in a flip mode while doing the homework, and then you come to the class and do the discussion. So this is the overall blended MOOC thing which is being running in by IIT Bombay X is based on those flipped classroom and peer instruction strategy. So one of the basic questions which arises when one go through these activities, or when one is participating in a blended MOOC, that what is the role of the instructor who is teaching inside the class. So there are two instructors specifically. So we have an instructor which is there in the online video, and then we have an instructor which is pretty much active inside the class. So it's not like that if you are an instructor, if you have participated in a blended MOOC and you are an instructor in a classroom, then you have no role to play. Actually, you are the main anchor who will orchestrate all these activities inside the class. So as an instructor, you have to follow this flipped classroom model, and you have to carry peer instruction activity inside the class to significantly improve the learning of the student and also significantly improve the engagement of the student inside the class. You will automatically try to notice the beauty of this flipped classroom model once you try to implement this uh, into your classroom. So through that, through the activity which have been posted on the Moodle, you will be seeing that there are certain activities which have been rightly put up, which asks questions on how to form a question using a flipped classroom model and the peer instruction activity as well. So when you go through that activity, you understand how in case of signal and system you can put up questions inside classroom using this flipped classroom model, as well as how to use the instructor video and how to, it is not at all required that whole of the video on a particular topic or on a particular lesson can be shown to the student. You can chunk the videos even further and you can add certain activities to that particular video using peer instruction activity, and then you can enrich student learning in the inside the classroom by teaching those concepts and topics. So I really emphasize that all the faculty participants really go through those activities, because this whole blended MOOC thing is theoretically based on those learning activities.
Hello, check.
So it's been gone for how long? Okay, so there was some technical glitch. So what I was mentioning is that it is very necessary to
Yeah, you can use this.
sorry for the interruption. So what I was pointing out,
Audio okay?
now audio is okay. So what I was pointing out, that all the activities which has been posted on the Moodle is really very important for you to understand that what is the role of the instructor inside classroom in a blended MOOC model. So until or unless you go through all the readings which have been posted on the Moodle, all the activities, all the lesson plans which has been posted on the Moodle, you will not be able to understand the beauty of this model. So I really emphasize all the faculty participants to go through all those activities, and I really hope seeing all of you completely involved in the discussion forum also on the Moodle. If you have any question, you can post your questions on the discussion forum. If you have any question regarding the flipped classroom model or the blended MOOC model or the peer instruction activity. So there are a number of teaching learning activities which you can do using this model. So with this, I will hand over the mic to Professor Gadre.
Thank you, Abhinav. And in fact, I must mention Abhinav, is of course doing his PhD currently with my supervision in the interdisciplinary program on educational technology. But before he joined the PhD, he has also been a faculty member in an engineering institution. So he has an idea. He is one among you, a colleague like a colleague. So he has a full idea of what instruction means, and therefore I strongly recommend that you take his suggestions seriously. Now let me call upon Ashwit to introduce himself. Come, just let him come and introduce yourself. And so Ashwit is my coordinating TA, and he's been in touch with you. So I would like him to introduce himself and say a few words about how he's experiencing the suggestions he has for you.
Good afternoon, everyone. I'm Ashwit Rego, and I'm an MTech student here at IIT Bombay, and also a TA for the Signal Systems blended course. And I would actually, so my main role is to actually manage all the course creation for the TA side. So your exams and the questions and all are managed by us TAs. And I would actually like to emphasize that we need to see more participation from your side in terms of participation in the discussion forum. So we are trying to put up posts. We actually put one post up on the discussion forum for the students, asking them to talk about systems that they see in everyday life, and to point out what are the inputs, what are the outputs, and what kind of processing goes on in the system. So there haven't been much replies. I would urge you to encourage your students to reply to all these. It's because it's only when you have these discussions that people will learn better. And we have to use the forums because that's the only interaction we have with each other. Since this is an online course, we don't have any face-to-face interactions between students. So I would actually urge you to reply to the forums. So that's it from my side.
Sure, yeah, come.
Oh, it's crowded.
So,
No, sorry for disturbing, but I was so excited. How many remote centers? 10. Good afternoon. Sorry. Mic is okay? Good afternoon. This is Deepak Phatak. I am the principal investigator of the project under which we are running this blended MOOCs. I am very excited to see multiple institutions interacting with Professor Gadre and his colleague. We have started similar interactions for CS 101X as well. In fact, next week, where we normally meet after 15 days on Tuesdays, next week, because Tuesday I am in Agartala, we scheduled it on Friday, and we are going to have our first interaction with actual students after the interaction with teachers ends. 2 to 3 we have planned teachers interaction, and 3 to 4:30 or 5 interaction with students. The only thing I wanted to suggest is, if some of the teachers are interested, after the teachers interaction every fortnight, you might want to schedule a students interaction for those students in those colleges who are interested and where the AView facility can be extended to a classroom. I thought it would be nice if in the presence of the local teachers, the group of students interact directly with our faculty. Anyway, thank you very much for participating. I hope you are uploading the students' data appropriately. There have been some glitches which we are being resolved, and I think we will soon get over this problem. I once again would like to compliment all our teacher colleagues for participating in this globally unique initiative, the like of which has not happened anywhere else. India is the forerunner in this experimentation. I can also inform you that there is a meeting of an AICTE committee on a Sunday in IIT Bombay to recommend acceptance of the credits earned by the students using MOOCs or blended MOOCs in their regular grading all over the country. So what you people have started jointly with our colleagues is going to bring a new wave of learning and teaching in the Indian education system. I just wanted to compliment you for that, and of course compliment my colleague Professor Gadre and others. Thank you so much. Sorry for interrupting.
So we were very fortunate to have Professor Phatak come and talk to us just now, and he is in fact giving you some good news. So let me now request Ashwit to complete. So Ashwit has now completed. So you can come again now. So now with this introduction to my teaching associates, my principal my PhD student Abhinav Anand, and my principal coordinating teaching associate Ashwit Rego, who has been interacting with you online, but I wanted them to speak to you face to face. And Professor Phatak also mentioning that we should have students come to this discussion. In fact, I have been looking forward to it. So I am hoping that this time also we have a few. If not, at least the next time we should definitely have interactions with students. But now let us go center by center. So let us begin with GH Raisoni College, Nagpur. I hope the video is okay, video and audio. First tell us if the video and audio are okay. Very good afternoon to all of you. So we don't get your audio. Can you please speak, check your audio from that side? GH Raisoni College, can we check your audio please? Audio. Audio. Huh? Are you able to hear us? Can you raise your hands please if you are able to hear us? No, they are not able to hear us. Okay, let us move to Amrita. Hello? Yes, hello, yeah, yes. Are you able to hear us? Can you raise your hands if you are able to hear us?
Yes,
Yeah,
sir.
you are.
Yes, sir.
Okay, very good. So let's have your questions and your interaction.
Actually, we are facing problem regarding uploading of .csv file. We are not able to upload that CSV file. So, as per telephonic conversation with IIT person, they have told us to mail that .csv file, and we have done it actually. But the thing is that the registration of all students are not showing successful. All students are not successfully registered there. It's showing like that. But when we have contacted our students,
So
they
I'm
are
going.
saying that
Okay.
they are already registered.
Right. Why don't you come? So maybe you can sit with me. So I'm just requesting one of the technical officers here to come and respond to your query. You can introduce yourself and then respond.
Hi, I'm Sandeep here. I'm project manager. The email ID and username should be same as given in IIT Bombay X website.
Username and email ID should be same.
Yes, as given in IIT Bombay X website. The file should be .csv file.
.csv.
Right. And then you may upload the same. If still you are facing any issue, you can put an email at eoutreach@it.iitb.ac.in.
So some of our faculty members, they are facing problem regarding uploading of that CSV file, in spite of uploading corrected format of the CSV file.
And one more important thing, suppose a student, he registers at IIT Bombay website today. So after 24 hours only he may upload the file. Means the faculty can upload only after 24 hours. That is one thing. Suppose today the student registers at IIT Bombay X website. So today only the faculty cannot upload. He can upload after 24 hours. That is one thing.
The second thing is regarding this is for faculties or for students, so that can convey to students what to do. Whether we have to do it.
He's asking what do students have to explain what the students have to do and explain what the faculty has to do. Explain both separately.
The thing is actually students, they supposed to register at IIT Bombay X website. Then they supposed to sign up for the particular course. And their username and email ID same as IIT Bombay X, the student supposed to give it to the faculty. Then faculty can log in to BMW Info website. He can download the template, and in the same template he'll write the student's roll number, username and email ID. Username and email ID should be same as IIT Bombay X, and the faculty is supposed to upload that file.
Yes.
I hope it is clear. If still you are facing any issue, you may put an email at eOutreach. You must be having the email ID or eOutreach, so that we can check it from our technical team, software team, what is the issue.
Actually, some faculties, they have already mailed you the that file which error is showing. Some of my faculty members are sitting with me. They are same problem. So that file has been uploaded mailed to you regarding that error.
Getting error. What error you are getting?
Sir, I'm giving.
Your voice is not clear actually.
Hello?
Hello? Yes, I am able to hear you. Tell me.
I'm not getting error actually. I have when I've uploaded, some students get registered and some they are saying they have not registered, but they have registered. It is written that it is not registered. So when it is saying for 19 students it is valid, that means it has been uploaded to your IIT Bombay account.
Yes, means you mean to say that few people they registered and few are not.
Yes.
Okay. So those
Yes.
who tell me.
My error is different actually. I'm getting an error only for few students, not for
Aaj.
all. For example, a few students who they have registered,
Mhm.
there and if they have valid user ID, then they are fine. It is uploaded. And for few students, they are saying the username is not valid. So
Ha.
username is it important a lot, or email ID should be fine?
No, username and email ID should be same as IIT Bombay X. So the username and email ID through which they registered on IIT Bombay X, same username and email ID it will accept.
Okay.
Hope it is clear.
One more question.
Hello.
Sir, one more question. One last
Yes,
question is
please tell
there.
me.
Most of the students they have registered with a different username.
No,
Should I
no,
say them to change their username?
it won't accept. Different username, it won't accept. Ask
Like
them to
I
registered
have
with the
shared one
same.
Google.
Ask them to registered with the same username and email ID as IIT Bombay X, and the faculty can upload the same file, means the same username and email ID. That file the faculty can upload only after 24 hours. That is the one more thing. Means
Okay.
today if
Thank
a
you.
student registers, so you cannot, faculty cannot upload on the same day.
Thank you, sir. Thank you
Yes,
so
you're
much.
welcome.
Is it? Let's see this. Thank you so much. So, are there any other questions from J.H. Rai Soni College? Any technical questions from your side?
No, sir. No.
Okay, so we'll go on to Amruta
No, sir.
Yashwantrao College of Engineering.
Only we are facing the problems for uploading the CSV file.
Okay, fine. Yashwantrao College of Engineering. Very good afternoon to all
Hello,
of
good
you.
afternoon. Good afternoon, sir.
Yeah.
Sir, if
Yes.
x of t equals to 1 for 0 less than small t less than capital T and 0 otherwise,
Yes.
and h of t equals to small t from 0 less than small t less than capital 2t and 0 otherwise, then how we will perform convolution of this?
Okay. Yeah, so let me write down x of t equal to 1 for 0 less than equal to t less than equal to capital T, and h t equal to t for 0 less than equal to t less than equal to capital 2t. Is this correct? Is this your question?
Yes, sir.
So, you want to convolve them, is that right?
Yes, sir.
Very simple. So, see here it is easier to keep the shorter sequence as the moving one. So, you can make this the train and this the platform, so to speak, isn't it? That is better. Now, let us sketch them. So, let me also, so this is, let us keep this as it is. H of t. Isn't it? And x of t looks like this. So, x of, in fact, what we will do is we will call it t1 here, and x of t minus t1. So, it goes from t to t minus capital T. Oh, we will say t here and t minus capital T here. So, this is x of t minus t1, isn't it? Now, you can visualize this moving along with as per t. isn't it? Now, as long as t is less than 0, you can see nothing comes out, because there is no overlap between this block and the function ht1. As bit for t between, now you see, you can visualize this train entering the platform here at 0 and then leaving the platform with t minus capital T hitting 2t. So, let us calculate. Now, there are, so how many regions do we have? We have a region where first this block does not completely overlap with this triangle. That will happen between 0 and capital T. Then you have a block where it overlaps completely and goes from t equal to capital T to t equal to 2t. And then you have a block in which this goes out, the train goes out of the platform. So, that is between t equal to 2t and t equal to 3t, and beyond that the output is 0 identically. So, let us take each of these three regions. Let us take the region 0 less than equal to t less than equal to capital T. What would the output be? It would be an integral from 0 to t of lambda d lambda, or if you want you can write t1 dt1, you know, maybe I will do that, I will write t1 dt1 so that you understand, isn't it? So, that is very easy, that is simply equal to t minus 0, well sorry, t1 squared by 2 from 0 to t, is it not? So, that is t squared minus 0 by 2, t squared by 2. Then you have a region where it overlaps completely. So, there you have integral t1 dt1, but it goes from, now you know it goes from t to t minus t. So, here it is the same thing, same integral t1 squared by 2, that does not change, but the limits are t minus capital T to t. So, you have t squared minus t squared by 2, you can simplify this. So, you get the sum 2t minus t, the difference, that is capital T divided by 2. And finally, you have the region, I will take a next page here. You have a region 2t less than equal to t less than equal to 3t. Now, there what happens? You have from t minus capital T only up to 2t, t1 dt. So, the same thing t1 squared by 2 integrated from t minus t to 2t, all right. This is where the integral goes. So, this is how you would calculate the, now you can simplify this, so I leave it to you to simplify. Now, what I would like you to do is, I leave it to you, all of you, as an exercise to evaluate and sketch this. And there is something very interesting you will see. When you sketch, you must comment on the continuity of the output. Is it continuous? Is it differentiable? So, you can see that it will be quadratic, in each region it will be quadratic in nature, but what I want you to study carefully is the continuity and differentiability, particularly at the points of transition, capital T, capital 2t, capital 3t and 0, right. So, I would like you to think about this, tell your students to do the same. So, have I answered your question, Professor? Can go to the video.
Sir, so, sir, how we have selected these regions 2t to 3t?
Yes. Yeah. So, you know, let us go back to the first slide. Yes. Bring some more paper. Huh? No, backwards. There's a back there. Huh? No? Let's go to the first. Yeah. Back. There's the back arrow there. Back. So now look at this. You see here, now you know that block below you visualize. In fact, what I'll do is I'll draw upon it. So we can visualize it as I told you, it's good to use the train platform analogy. So maybe I'll change that. Is it possible to change the color here? Yeah, this one. No? Yeah. Let me change the color. Let me make it red. Now the train. This is the train here, and this is moving along the platform. Now this is the front coach and this is the rear coach. Now what you have to visualize is that there are three regions. The first region is where the front coach is behind the platform, there nothing comes out, so it is all 0. The next region is where the front coach has entered the platform, but the rear coach has not entered. That is the region from 0 to capital T. Then you have the region where the whole train is inside the platform, that is the region between T and capital 2T, capital T and capital 2T. And finally you have a region where the rear coach is inside the platform, but the front coach has gone out of the platform, where that is the region between 2T and 3T. And then both the front and rear coach, the whole train has gone out of the platform, that is the region beyond 3T. That is how you visualize. Is it clear, Professor, how you visualize these regions? So there are actually in that sense 5 regions, 3 of them where there is a non-zero output, and the other 2 before 0 and after 3 the output is 0. Is that clear to everybody?
Thank you, sir.
Is it clear? Is it clear to you?
Yes, sir. Yes, sir, it is clear.
Okay, very good. Yes, what you should do is, you should all calculate, now since we have discussed this question, you should all calculate the answer and you can put it up on Moodle for everybody to see, right? In fact, what we can do, let us take this as an exercise for all the blended MOOC participants. So all of you can work out this exercise and you can put it up on Moodle and you can discuss the question that I have given you, the continuity and differentiability of this, okay? Yes?
Okay, thank you, sir.
Any other questions, Professor and Yashwant
No, sir.
Rao? Any other questions?
No, sir, thank you, sir.
Thank
No,
you.
sir,
I hope
thank
you are you all enjoying the course? Are you going through it?
Yes, sir.
Okay, thank you. Now we will go on to Geetham University, Hyderabad campus. Good afternoon.
Hello, sir.
Good afternoon. So,
Is it,
do you have any questions?
Good afternoon, sir.
Good afternoon.
Sir, regarding technically questions is there, sir. Before that, some normal doubts record registration is there. First, I will ask that, sir.
Right. Yes.
Sir, first of all, our Moodle login ID is ID and password is not working. We already sent an email to e-outreach, and what is our name and what is the mail ID that I used. Both coordinators.
Sandeep will answer.
Yes. Have you sent the email?
I sent an email to e-outreach that regarding login ID and password of Moodle.
So definitely we will check the same and reply back to
Actually, you said the procedure, click on the forget username and password.
you. Right, that is correct.
Okay, sir. Thank you. Sir. And one more thing is, sir, you are saying that we have to send a CS file where I have to roll number and username. That username is in registration, whether it is full name or public username.
The username which they have given in the IIT Bombay X website, public username. Your audio is not there. I am unable to hear you.
Okay. Okay, sir. That means there, first one is full name is there, sir, in registration process, and public username is also there. So that's what we are asking, sir.
See, the name which it reflects when the student logins to the IIT Bombay X website, top right hand side you will see the name. So that name.
Okay, sir. చెప్పట్లేదు.
Yes, any other question?
Hello?
Hello?
Yeah, go on.
Yes, please go ahead.
Sir, another query is nothing but students are not written assignment. So you given quiz 1, no, sir. If they doesn't written anything, whether it depends their grade.
So I am going to ask my coordinating teaching associate Ashwit to tell you a little bit about the quizzes and evaluation, right? So Ashwit, come.
Is it?
So there are actually 4 quizzes in the course plus a midterm and an exam. So in order to get us to pass the course in the online platform, you need to get 40% marks. Okay, so the grading policy has been uploaded online. You can check that. Now the first quiz is over. In fact, we even extended the deadline till today afternoon. So beyond that, we cannot extend. There are 3 more quizzes. Now the thing is, out of the 4 quizzes, we take the best 3. So if people have missed the first quiz, they can still get a good grade even if they answer the remaining 3 quizzes. So please ask your students to make it a point to answer the other 3 quizzes properly. The quiz will be released on a Wednesday. So the quizzes are released after every module. So module 1 just got over after the first 3 weeks of the course. Once module 2 gets over, there will be a quiz 2. We'll also have midterm after module 2. So, and also it's also important to know that all of these graded assignments are open for only 48 hours. So ensure that the students, attempt them quickly.
Okay, sir. Okay, sir. Regarding technical question, one question.
Yes, please go on.
Y of t equal to
Paper.
y of t equal to e
Yeah.
power x of t.
E
Is
to
it
power-
stable system or not?
Acha, e to the power x. All right, I'll take that.
Y of t equal to
Yeah.
e power x of t. Is it stable or not?
Yeah, sure. I'll just answer that. One minute. So we have y of t. Oh, anyway, it's okay. Y of t is equal to e raised to the power x of t. Is it stable? Is this your question?
Yes, sir.
Yeah. Now see, how do you test stability? Give a bounded input to the system. You are going to test bounded input, bounded output stability. Give a bounded input to the system. Bounded input means there exists an mx greater than equal to 0, so that mod xt is always less than equal to mx for all t. Now you want to test what happens to the modulus of the output. Let us see. Now modulus of the output is going to be modulus of e raised to the power xt. Now here we will need to split xt into its real and imaginary parts, right. So you see, now e raised to the power, you see, obviously xt is of the form xrt plus jxit, is that right? And mod e raised to the power x of t is equal to mod e raised to the power, of course, xrt plus jxit, where xrt and xit are the real and imaginary parts. As a function of time. Okay. Now this is the same as mod e raised to the power xrt, because e raised to the power jxit has a magnitude of 1, or if you want, let me write it down. But this has a magnitude of 1. Now Now, if xt is bounded, obviously mod e raised to the power xrt is definitely less than or equal to e raised to the power mod xrt, all right, and that is less than or equal to e raised to the power mx, which is of course finite. This has to be finite, and therefore yt is also bounded. So, if xt is bounded, yt also turns out to be bounded. So, the system is stable. Is that clear?
Yes, sir. Yes, sir. System is stable system.
That is right. So, any other questions that you have?
Sir, one more question, sir.
Yes.
One more question, sir. Whether differential equation is differential equation of the system is
Yes,
stable or not, sir?
Differential equation of the system is stable. What do you mean by that? Do you know? Are you thinking about a particular differential equation?
No, sir. Any general equation.
No, in a general case we cannot say. It would depend on the parameters of. So, if a differential equation describes the system dynamics, then just because there is a differential equation you cannot say whether the system is stable or. If you have to look at the parameters of the coefficients. If it is a linear constant coefficient differential equation, then you need to look at all the coefficients to come to a decision on stability or otherwise.
Okay, sir. Okay. So I will give to one of another coordinate.
Yes.
Sir, can you give some inputs related to Gibbs phenomena, sir? How to explain Gibbs phenomena clearly?
Yes.
Is it possible to explain now, sir? Gibbs phenomena, sir.
Which Gibbs phenomenon? How to explain it? You want me to talk about
Gibbs phenomena, sir? Fourier series will be getting that problem.
Yeah. So how do you explain Gibbs phenomenon?
Sorry, sir.
Okay. See, the best way to explain Gibbs phenomenon is to realize. So one way to understand is this. See, in a very crude way. What are you trying to do when you truncate a Fourier series? When you truncate a Fourier series, you have obviously a continuous function after truncation, because it is a sum of finite number of sine waves, right. So, there is no choice but for the function to be continuous, in fact continuous and infinitely differentiable, because you have a sum of a finite number of sine waves, and you are trying to use that as an approximation to a discontinuous function. So, where will the problem come? The problem has to come at the point of discontinuity. Wherever there is continuity, there is going to be no problem, because you are trying to approximate wherever there is analyticity. For example, if I take a square wave, so if we take a square wave and we try to represent it with its Fourier series, what is going to happen? Now, let us identify different regions of this square wave. So, this is a region where it is analytic in this region. In fact, it is continuous, and in fact, derivatives and all subsequent derivatives are 0. It is analytic here. But there is a problem here. There is a problem here, discontinuity. So, here it is very clear that no matter how many terms you include, when you truncate the Fourier series, what happens here? You are going to try and describe this with an analytic function. That means a function which is all derivatives. Now, obviously, if you are trying to describe a discontinuous part of the function with an analytic function, you are going to have trouble. What kind of trouble? The analytic function will keep giving you oscillatory, you see, it's a sum of sine waves. So, it is bound to have oscillatory character, and that the troublemaker oscillatory character, when you put more and more terms, is going to behave well after the discontinuity and before the discontinuity, but at the discontinuity nothing that you do will ever improve the situation, because if you truncate the Fourier series, you still have an analytic function, you are trying to approximate a non-analytic function with an analytic function. So, what is going to happen? You are going to have a continuous concentration of trouble around the discontinuity. That is what Gibbs phenomenon says. Now, exactly how this happens can be explained by convolving the spectrum of what we call the truncation window with the spectrum corresponding to the original signal. So, there is a convolution involved there. Now, that can be explained in detail, but if we want to explain to the student, this is the simplest explanation to give. You are trying to represent a non-analytic part, in fact a discontinuous part of the function with an analytic function, a function which has all derivatives. So, obviously there is going to be trouble at the point where there is such a conflict, and the trouble will start getting concentrated near the conflict as you increase the number of terms. Is that all right? Is that clear?
Yes, sir. Yes, sir. Thank you, sir. Thank you very much.
Okay. Any other questions?
No, sir. No questions. Thank you very much.
Very good. So, now let us go on to FET Modi, Institute of Technology. Very good afternoon to all of you.
Good evening, sir.
Good evening.
Sir, it's me, Satyajit Anand.
Yes, hello Satyajit.
Sir, I am taking class here at DSP, and I have one question.
Yes.
Based on signals and system.
Yes, please go on.
Okay, okay, sir. Actually, sir, question is based on system is stable or unstable. That is for the case of discrete.
Okay.
Question is, sir, question is y of n equal to n into x of n.
Y of n equal to n times x of n. Let us see. Okay, yes, go on.
Yes, sir. Question is that, sir, if I apply what we have a condition bounded input, bounded output condition,
yes,
that system leads to unstable.
Yes.
But sir, again we have a second, what we have second approach to find whether the system is stable or unstable. That is square absolute summable.
Okay.
I mean absolute square summable.
Absolute summability of
so
the impulse
question
response.
is if we
Yeah, go on.
Hello.
Yeah.
If we apply second approach over this problem, that is absolute square summable, that should be finite.
Okay.
That is summation n equal to minus infinity to plus infinity mod h of n whole square is less than infinity, we say system is stable. So here, if we apply this formula over this equation, we are getting the system is like stable. So we have contradiction statements, sir. One side we are saying system is stable, and for other approach I am saying system is unstable.
Okay. Okay.
So could you help me, sir?
Yes, certainly. Now, firstly, you see that condition. You see what you said is you looked at the impulse response. Now, the impulse response characterizes only linear shift invariant systems. So, for a system which is either non-linear or not shift invariant, the impulse response does not say much about the system. For example, this system, clearly this system is linear, isn't it? You can see it is linear, because if I apply x1 or 2 of n and the output is y correspondingly 1 or 2 of n, and now if I apply alpha times x1 n plus beta times x2 n, the output is going to be alpha times y1 n plus beta times y2 n, and this holds for all alpha beta x1 x2. So, the system is linear clearly. Now, let us take the question of shift invariance. I think we can take a new page. Yeah. So, now let us look at the question of shift invariance. Now, what does this system do? Let us take y of n is equal to n times x of n. Suppose you apply an impulse, that is you apply xn equal to 1, as you said, for n equal to 0 and 0 otherwise, and ask what is yn. You can see that yn will be 0 for all n. On the other hand, suppose you shift the input. So, this looks like this. At 0 there is a 1 and there are zeros everywhere else. Now, you apply x of 1 at n equal to 2 and 0 else. How will this look? At 2 there will be a non-zero value and there will be zeros everywhere else. Okay. Now, what will the output be? Y of n will be equal to 2 at n equal to 2 and 0 everywhere else. So, now you have a non-zero output yn. In the first case you had a 0 output for all n. So, obviously the second output is not equal to the first output shifted by 2 samples. So, the system is clearly not shift invariant, isn't it? Yeah. So, clearly, yeah. So, clearly the input is, the system is not shift invariant. Is that right? Now, because the system is not shift invariant, it is not correct to apply the principle of absolute summability of the impulse response. That condition cannot be applied here, and therefore, you must test the system for its stability or otherwise ab initio. That means, you must check whether there are bounded inputs for which you have unbounded outputs, and if so, the system can be declared unstable. And indeed, if you take a unit step input, if there is a step input starting from 0, it gives you an unbounded output. So, therefore, there is a bounded input which gives you an unbounded output which makes the system unstable. Is that clear, Satyajit?
Yes, sir. So, not clear, sir. Thank you so much, sir. One more question, sir.
Yes, certainly. Yeah, sure.
Thank you so much, sir. Sir, question is again based on basic of signals and system. That is, we have a causal signal and we have a causal system as well. Question is, sir, if suppose if we apply the concept of causality over signal and system both, what we have a basic concept that when t is less than t naught, some parameter, suppose we have t naught. So both case we say this is a causal system and this is a causal signal. Is it a right concept, sir?
See, the notion of causality of systems is well defined. Now, for signals, the word causality is not actually very correct, but you can loosely, some people like to say that, they talk about causal signals. What they really mean is a right-sided signal. So, signal starts from some point onwards. That is what they mean by a causal signal. So, then for example, suppose a signal starts from point t0 onwards. That means, before time t equal to t0, the signal is 0. Then the output in a lead, if you have a signal like this which is right sided, that means it is 0 for t less than equal to t0, for all t less than equal to t0. Then when you convolve, or if you give this to a system which is causal, the output cannot start before t equal to t0, that can be said. Okay. Is that clear?
Sir, if I say that, yes, sir, if I say that causality is the property of a system, it is not the property of a signal. Is that right statement?
That is a correct statement. Causality is a property actually of a system, right? However, right-sidedness or left-sidedness is a property of a signal. So, you can say a signal is right-sided. Right-sided means it is non-zero only from t equal to t0 onwards, or it is 0 up to t equal to t0. That is a more correct way of saying it. So, it is said to be right-sided. You can say a signal is left-sided if it is 0 only, if it is 0 for t greater than or equal to t0, for some t0, right. So, signals can be right-sided or left-sided, but it is not really correct to say signals are causal or non-causal, alright.
Yes, sir. One more question, sir.
Yes, sure.
Sir, actually, what we have a definition of causal system, that is what we have input xt equal to 0 for t less than t naught.
Yes.
So yt should also be 0 for t less than t naught.
Very good, yes.
In that case, the system is causal. Other way to define this system, that output of the system depends on present and or past input, but should not future.
Yes.
This is also causal system. So how we can correlate these two definitions?
Okay, very
these
good.
Two statements would be same?
Yeah, alright. Now see, it is not really correct to say that, so causality in general, you talk about causality in general, what it means irrespective of linearity. See, one must not mix the two. So causality means in general if two inputs are identical, up to t equal to t0, then the outputs, the corresponding outputs are also identical. Up to t equal to t0, all right. Now, let us take an example. Suppose you have y of t is equal to x of t minus 2 plus 3. Obviously, the system is causal. However, if you give a 0 input, the output will continue to be just 3. So, the output need not be 0, and that 0 output which you are talking about will only happen if the system is also linear. So, linear system, a linear causal system will have this property that if the input is 0 up to a point, then the output is also 0 up to that point, and the reason is simple. If you give an all 0 input to a system, to a linear system, the output has to be all 0. In fact, you do not even require linearity, additivity or homogeneity is sufficient. If a system is additive or if a system is homogeneous, then an all 0 input to the system gives an all 0 output, we can prove that. So, if an input is 0 up to a point in time and if the system is additive or homogeneous and it is also told to be causal, if you are also told that it is causal, then you can conclude the output is also 0 up to that point. But additivity or homogeneity is required in addition to causality. Otherwise, all that you can say is whatever be the input for a 0 all 0 output will be, whatever would, suppose you took an all 0 input and studied the output, then as long as your input is 0, the output would match exactly the case of the all 0 input up to that point. That can be said. Is that clear?
Yes, sir. Thank you so much, sir.
Very good, nice, very good. I am very happy that you asked some good questions. I think everybody is asking good questions. Any other questions from FET Modi?
No, sir. Thank you so much, sir.
Okay, thank you so much. Let us go to KJ Somaiya College of Engineering. We are not able to catch your video. Oh, the camera is not on. Okay, while they sort that out, let us go to Amrita Vishwa Vidyapeetham. They are not publishing the video. Okay. So, let us then go to NMIS MS Shirpur. Yes. KJ Somaya has come. Yeah. KJ Somaya has come. So, let us go to KJ Somaya. Yes. Yes. Good afternoon. There is no audio. Please check your audio.
Sir. Sir, impulse signal exists at t equal to 0, where we define it as the amplitude is infinite and the area is 1.
Okay.
Hello?
Yes, go on, go on. You are talking about an impulse and you said the amplitude is infinite and the area is 1. Okay.
Hello?
Yeah, we can
when
hear
we
you.
take a product property, amplitude is infinite.
Yeah, the amplitude, you said the amplitude is infinite but the area is 1. Alright, go on.
X of A.
It's a bandwidth problem.
Here we don't talk in form of an amplitude, we speak it in form of area only.
Yes.
Product property and shifting property as well.
Yeah, yeah.
Why is it so? Students have a doubt why we are not multiplying the amplitude at a particular instant.
That's right, yes. So, you know, when you talk about multiplication of a continuous function with an impulse, you should not think of it as a point by point multiplication. It is a multiplication all over the time axis, and the behavior is in terms, so you can only explain what the impulse does under an integration sign. So, you must think of it as an object which has a sensible behavior under an integration sign. As long as you have not integrated, it is not possible to describe what you get. That is why it is called a generalized function. It is not a function in the regular sense, it is a generalized function. So, you can only explain how it behaves under an integral sign. Is that clear?
Okay.
You are not receiving your audio. All right, we will go on to next. Let us go on to Tyagaraja College, or what was the other one we took in between? Tyagaraja College. Let us go to Tyagaraja College, Madurai. Yeah. Yes. So we'll. Yes, Tyagaraja College. Yes.
Hello, sir.
Good afternoon. Yes.
I gave you a question.
Yes.
Y of n.
Yeah.
Is equal to x of 2n.
Okay. Y of n is equal to. Yes. Go on.
X of 2n.
Yes.
Is it a time invariant system?
Okay.
Or time varying system?
Okay.
We had a very good discussion in the class.
Okay.
Okay. Is it a time shall we say it is a time invariant system, sir?
So it is it's not time invariant. Now let us see why not. It's very simple. You see, let us do the very simple exercise of shifting by one step. So let us have n and xn like this. So xn is equal to say 8 here, minus 6 here, 4 here, 7 here, 10 here, minus 3 here, 6 here and minus 2 here. Okay, this is x of n. Now what will be the output y of n at each of these points? At 0 it will be 8, at n equal to 1 it will be 2, this comes here. At n equal to 2 it will be 10 and so on, and n equal to minus 1 it will be 6. and so on. Now shift x by one step. So what will happen? You delay it by one step. So you get minus 2 here, 6 here, minus 3 here, 8 here, minus 6, 4, 7 and so on. Okay. Now what will be the output? Let us put in a different color. So what will be, let me put it in black again. So what will be the output, the corresponding, so what will be the corresponding output sequence here? At 0 it will take the value which this has at 2. So what value does this have at 2? Minus 6. Then at 1 it will take the what value this has at 4, which is 7, and so on. And here what is going to happen? At minus 1 it is going to take the value which it has at minus 2. So you get minus 2 here and all that. Now if you compare this and this, so this and this are totally unrelated. So the output that you get when you shift by one step is totally unrelated to the outputs that you got when the original sequence was given. So obviously, if the system was shift invariant, then when you shifted the input by one step, you should have got the output shifted by one step also. No other change should have taken place. But here you get a totally unrelated output. Now the beauty is, if you shift the input by 2 steps, you will see the input shifting by one step. So some people may mistake this to be shift invariance. It is not shift invariance, because if the input is shifted by 2 steps, the output gets, in fact if the input is shifted by a multiple of 2 steps, the output gets shifted by half that shift. And so people tend to think it is shift invariant. It is not shift invariant, because if you shift by an odd number of steps, you get a totally unrelated output. Is it clear?
Yes, sir. In some books they say it is periodically time invariant.
Yes.
Is it correct, sir? This one.
That can, it's see, in fact that is also not quite correct. Books like to make terms complicated. So when you say periodically time invariant, then you are saying that it is time invariant for some shifts. That is not really correct, because if you shift by an even number of samples, the shift is by half that amount, not the same. But yes, what you are saying is correct. If you take, see, if I also put into this another step of pushing zeros between successive samples, then you can get what you are saying. It is, so if I I'll show you a system which is what you are talking about, which has some periodic behavior. Yeah. So let's take a system which has that periodic behavior they are talking about. Let us define y of n is equal to x of n by 2 whenever n is even, and 0 when n is odd. Now here we can say periodically shift invariant. Because if I shift the input, now here again, see, actually even here it is not very correct. This is not very correct, but still I'll, see, here what happens is, all that you have done is you did what you did previously, and then you pushed the samples by one step back. So if you cascade the original system and this system together, so now the net system, so if I take the net system like this, yeah. So cascade this with the previous system. and therefore now the resultant will be that y of n. So previously it was x of 2n and now it will be x of n. So you get y of n is x of n whenever n is even. Okay. If we take this and 0 when n is odd. Now here what you are doing is you are retaining the even samples as they are and throwing away the odd samples, making them 0. Now if you shift by an even number of steps, you indeed continue to get the same output shifted by the same even number of steps. So that can be called to be periodically shift invariant, but not the system which you talked about. That is not periodically shift invariant. Okay, is that clear?
Thank you, sir. Yes, sir. My colleague has one question.
Yes.
Sir, in the book it is said that unit step signal is running some integral of unit impulse signal.
Yes.
That is u of t equal to integral minus infinity to t del of tau d tau.
Yes.
So how to explain this unit step signal?
Okay. See,
because unit step signal it only for t greater than or equal to 0.
Yeah.
Here the u of t is equal to running some integral of minus infinity to t del of tau d tau. So how to explain this?
Okay, good. So you see, what does the unit impulse do? It's like, you see, a unit impulse you can think is like a small balloon which has area encapsulated inside. So every time you go past the balloon bursts and throws that area out. Until you reach the balloon, nothing happens. But the moment you go past the balloon, it bursts and releases that area. So what happens when you make a running integral? Until you reach 0, the balloon doesn't burst. But when you cross 0, the balloon bursts and then that area is released and the area remains at 1 afterwards. Okay? That is the way you can think about it.
Okay. Thank you, sir.
So any other questions from your side?
No, sir. Thank you, sir.
Okay, thank you. Good interacting with you. Good question. Now let's take the next center now. College of Engineering, Pune, Maharashtra. So COEP. So any questions from COEP? So we are not getting your audio. Can you please check? So, yeah. Okay, there is a question from Geetham University, Hyderabad campus.
So good afternoon, sir.
Yes.
Question is delta function in continuous and discrete, whether it is causal signal or non-causal signal. So I got the answer delta of t is non-causal, whereof delta of n, what is the answer that I required, sir?
See, firstly, the word causal signal and non-causal signal is inappropriate, right? That is not a correct way of describing. And for the unit impulse, actually, if you look at the unit impulse in continuous time, there are different ways of arriving at the unit impulse. You can arrive at a unit impulse by starting from a pulse which is only right sided, or you can arrive at a unit, by right sided I mean which exists to the right side of 0. Or you can arrive at a pulse by starting from, you can arrive at the impulse by starting at a pulse which is non-zero only for the left side of 0. Or you can arrive at an impulse by starting with a pulse which is on both sides of 0. So it is not really correct to talk about causal and non-causal signals, and particularly when you talk about the unit impulse, there are many different ways of arriving at the unit impulse. So maybe this question is not, one should not ask whether a signal is causal or not. The answer is that right sidedness or left. So you can have the unit impulse come from a signal which initially was non-zero only to the right of t equal to 0, or only to the left of t equal to 0, or which had non-zero parts on both sides of 0, is that right? In the discrete case, of course, the unit impulse is very well defined. It is a sequence which is 1 at n equal to 0 and 0 everywhere else. So, in that sense, it is easier to understand the unit impulse in discrete time. Okay.
Okay, sir. One more question. Duality. Why only it has? Why only it is in Fourier transform, whereas Laplace transform there is no duality.
Okay, okay, that's interesting.
Duality property.
Very good, good question. So, see, in the Laplace transform also there is a limited form of duality. For example, if you differentiate the Laplace transform, there is effectively some kind of a multiplication of t involved, and if you multiply by t, there is a differentiation of the Laplace transform involved. See, I mean, loosely, in a broader sense, there is some kind of a duality, right, but there is a limited form of duality. For the Laplace transform has a limited form of duality. So, let us write both the Laplace transform and the inverse Laplace transform. X of s is integral x t e raised to the power minus s t dt. This is the Laplace transform. Now, I can differentiate both sides. So, you get minus t times x t e raised to the power minus s t dt, is it not, when I differentiate with respect to s. And similarly, I can, next page, I can write the inverse Laplace transform. So, I can write x of t is 1 by 2 pi j integral from sigma minus j infinity for fixed sigma to sigma plus j infinity capital X s e raised to the power s t ds. And now again you can differentiate both sides with respect to t and pull in the differentiation inside the integral. Now, you will get s times x s e raised to the power s t ds. So, you can see there is some limited form of duality here. Multiplication by t, or rather minus t, corresponds to differentiation in the s domain, and multiplication by s corresponds to differentiation in the natural domain. So, there are limited forms of duality in the Laplace transform also. But in the Fourier transform, the duality is much stronger, and the reason is, if you look at the Laplace transform expression and the inverse Laplace transform expression, though they are similar, they are not as similar as the Fourier transform and the inverse Fourier transform expression. That is why the duality is more limited in the Laplace transform. Is that clear?
Okay, sir. Okay, sir. Thank you, sir. Thank you very much.
Okay, now we can go on to NMIMS, that is in Drouet. So, do you have any questions from Drouet?
No, sir.
You have no questions?
No questions, sir.
Okay, thank you so much. Then we will go to VNIT, Nagpur. All right, then we will go on to Agartala, NIT Agartala. Very good evening.
I am audible. Good evening, sir.
Wait, speak into the mic, we can't hear you. Speak slowly.
Can you hear me, sir?
Yes, now I can hear you, yes.
I'm unable.
Wait, your mic is going away, so we can't hear you. Speak clearly into the mic, yeah?
Am I audible? Am I audible?
Yeah, I think it's not close enough to the mic. No, it's not close enough to the mic. Maybe you can speak loudly and speak directly into the mic. I could hear you earlier.
Am I audible, sir?
Now you are audible, yes.
Sir, I am Anirban Bhattacharya from NIT Agartala.
Yes, Anirban, welcome.
Today I have a question on impulse response.
Okay.
How do we get the impulse response from differential equation describes a linear time series?
Can you repeat your question? How do you get the impulse response from differential equations?
Which describe the linear time invariant.
So you are saying that there is a differential equation which describes the linear shift invariant system. That means a continuous time. Obviously, it has to be a continuous time differential linear shift invariant system, and you want to find the impulse response from there. Is that right? Yes. Is that what you are asking? Yes. Now, there are two ways of doing this. One way is to go directly from the time domain. So, one time domain approach is depending on the differential equation. It is very rarely that you can find the response to an impulse directly. Normally, it is easier to find the step response. And then differentiate this. I will take an example. Suppose you have a first order system. So, let us take a simple RC circuit as we had in the course. Let us call RC equal to tau, and the output voltage is y of t and the input voltage is x of t. So, what is the differential equation describing this? Output voltage plus the voltage across the resistor, which is R C dyT dt, is equal to the input voltage, or y of t plus tau dyT dt is equal to x of t. Now, you can find the step response of this circuit. So, let us write down the step response. The step response of this circuit is y of t is 1 minus e raised to the power minus t by tau times ut. So, it will look like this. The step response will look like this. See, it will start, the capacitor initially cannot have non-zero voltage, it will rise to a voltage of 1 exponentially. That is how it will look. Now, you can take the derivative of the step response. That will be minus of minus 1 by tau e raised to the power minus t by tau ut. You have to do it by the chain rule, plus 1 minus e raised to the power minus t by tau delta t. So, you see, if you look at 1 minus e raised to the power minus t by tau delta t, here you need to evaluate this at t equal to 0. So, 1 minus at t equal to 0, this is also 1. So, this simply becomes 0. This term does not contribute. So, the differential, the derivative is only this. Therefore, the impulse response of this circuit would be one by tau e raised to the power minus t by tau times ut. That is the impulse response. So, very often it is convenient to find the step response and then differentiate to get the impulse response. You can also do other things. For example, you can find the response to a unit ramp and then double differentiate. In some cases that might be better. It depends on the number of integrators in the system. So, you can see very rarely does one find the impulse response directly. There are some rare situations in which you might be able to find the impulse response directly, right, in the time domain. Now, an easier way to approach the problem is to go to the Laplace transform. So, if you take the system function and find the inverse Laplace transform, you get the impulse response immediately, alright. So, is this clear? Is your question answered?
Yes, sir. I'd like to.
Yeah, wait, speak slowly into the mic, and speak into the mic directly.
That's it.
Okay, any other questions? All right, thank you so much. Yeah, so Yashwant Rao, Chavan College of Engineering, you have raised your hand, so do you have a question?
Yes, sir.
Yeah.
Sir, why we generally do signal analysis in Fourier domain and complex system analysis in Laplace domain?
Okay. You see, the signal, normally we find it, well actually it is not really true that you will only do system analysis in the Laplace domain, you can also analyze signals in the Laplace domain, but very often you see the idea of system function is more general than the idea of frequency response. So, for example, when you want to deal with unstable systems, then you need to take recourse to the Laplace transform, and you also need to use a system function, and you cannot have a frequency response there. So, in that sense, the Laplace transform allows you to deal with a wider class of systems. It allows you to deal with at least some of the unstable systems that there are, right, and also signals that are not summable and are not integrable. So, if a signal is not absolutely integrable, then you might be able to use the Laplace transform, but you definitely cannot use the Fourier transform, right.
Okay, sir. Thank you.
Any other questions from your end?
No, sir.
Okay, very good. So now we have I think we have gone to all the centers. If any of you have a question, please raise your hands. You can raise your hands online if any of you have a question. All right, in that case, okay, so in that case then it is indeed delightful that we had so much of interaction with several of you. I am glad that many of you have raised technical questions and we have been able to discuss some very interesting points and technical issues and also certain administrative issues. Let us again have an interaction soon. Now keep your eyes open for our next announcement of the interaction, and please bring your students as well the next time for the interaction. If you want, you can have some interaction just with the faculty initially, and then after some time call your students and allow them to interact also. We look forward to interacting with your students, and thank you so much for being with us today, and we are very happy that you asked so many questions and conducted a very successful live interaction session. Thank you and good evening.